Hey, Weather Warriors. In this video, I'm going to be taking a shot at forecasting the track, timing, location, snowfall amounts of this potential powerful winter storm that's going to track up the East Coast this weekend. I'm going to be also going over what this mystery question mark means. Something interesting could happen to the storm as it approaches Maine in this episode of Weather Decoded TV. Alright, you're probably wondering, what in the world does this map mean here? We'll go over that in a second, but first, if you're new to the channel, I invite you to make yourself feel at home, subscribe if you like educational weather forecast breakdowns just like this, and introduce yourself in the comments below. Also, guys, I'm thinking about creating a channel for the East Coast, the Central US, and the Western US. Let me know if this is a good idea in the comments so we have a community of, similar people in each area. So let's get right into it. I'm going to be unveiling what this map means here later on in the video. We're going to go hour by hour here, and I'm going to show you how this storm evolves as it moves into the East Coast. All right, guys, we're going to be using the high-resolution Canadian model for this event as I think it's been the most consistent, and it does pretty well for the East Coast. We're looking at Friday night at 7 p.m. You can see a low-pressure system developing right over Tennessee and North Carolina. You got a warm front kind of developing up here. This is kind of your temperatures in the atmosphere, your average virtual temperatures, and when you get these gradients to develop, that's a sign of a front. See, there's a big one over here. That's your cold front developing. You got a 540 line here, which is your average virtual temperature being freezing between the surface and just below the jet stream. Well, what does that mean? Typically, it means snow. However, you're not quite getting that here, so it's not always consistent. I would forecast a cold rain out there. But as we get towards Saturday morning at 6 a.m., look what happens here. This thing deepens. It's a 996 low. The lower numbers you get, the stronger typically these storm systems will get. You have a very nice cold front developing. See where those kinks are? And here's more kinks right here. There's a warm front developing over here. That comes back and occludes there. That's your low pressure system, a decent stream of moisture along that front. That gets wrapped around, and east winds blow this right into this conveyor belt of a low pressure system here, and you can see snow breaking out in the mountains, West Virginia, upper elevations, Pennsylvania, and even some wet snow way north of that warm front. However, I think this is going to be a little bit overdone with the snow early on. As you see in my previous videos, I've said there's going to be a cold air issue and a timing issue with this system. I think the cold air is going to come in a little bit too late. Your main polar air mass is all the way out here. This area right here is storm generated. So the storm's kind of generating its own cold air when it gets really strong, but it also needs to pull in from an Arctic air mass to really get a decent snowstorm. That Arctic air mass I'm forecasting, it's just going to be coming in a little bit too late. However, as we get farther north and later on into the event, farther north, that could change. Here's the low pressure system, 985. This is Saturday night at 7 p.m. We'll go a little bit farther north so you can see that. Look at this, the GEM computer model breaking out a heavy batch of snow far north of that warm front. I don't think there's going to be as much warm front snow as these models indicate. I think your main snow is going to be on the back side. It's called the deformation band when that main Arctic air mass comes in. So I think this might be just a little bit overdone at the moment. However, the Canadian model, the track, I think is looking pretty good here. You can see that cold air getting wrapped in. You can see that air mass a little bit farther south, but not quite there. This is the 540 line, and you'll notice that there's snow south of that rain to snow line typically. That 0 degree virtual temperature line. So when you see that indicated by the models, this indicates a slushy snow, probably won't stick to the surface, but very heavy, wet, and kind of a mixed rain snow ordeal. Now it's time for the Thunderhunter method that I talked about earlier in the video. And we're going to go over what in the world is that. It is time. Are you guys ready? Let's get right into it here. This is the potential for thunder snow. And how do we find thunder snow? Well, we're looking at the vertical velocity. This is Saturday morning at 6 or about 4 a.m. or so. And this is that same time period. Here's the low right here. You got vertical velocity values of -30 or below. When you typically get that, and when you overlay it with relative humidity, which we're looking at now, of at least 80% or so, that is a good sign that you're going to get potentially some thunder snow. And you see the potential is at least there for the southern parts of Maine as an area of lift moves north, and then also northern Maine. You can see that as well. That's essentially measuring the lift in the mid-levels, 700 millibar. If you have fast rising motion, you get friction, which can create some lightning. So that's your little fact of the day here. Something interesting, we're going to switch to the European computer model. I'm going to go back a few frames. The European computer model is a little bit slower with this, but look at this. This is now the vorticity. This also measures lift in the storm organization. It is much, much stronger than what the Canadian was showing. See the Canadian, this is a little bit later on, but you can see the European computer model. Look at how much stronger this is. A 978 millibar low, very strong, very powerful moisture coming up north, a strong, powerful deformation band behind it, indicating again wet, heavy, sloppy snow. So probably even if you do get strong winds, which you would get some very strong winds with this, it's going to be wet. Probably wouldn't blow around as much as it would if it was powdery. So that's good news. However, again, very strong snow on the backside, and I would expect 1 to 3 inch hour rates, maybe some thunder snow with that type of look. We'll switch back to the RDPS and we'll go again early in the morning here. We're going to wee hours of the morning, and we're going to see this track to the northeast. You can see the RDPS forecasting a very heavy batch of snow from Maine, New Hampshire, Vermont, New York, even down to Connecticut potentially, of heavy sloppy snow. Here's our 540 line. You can really probably have a good chance of snow as you head towards Vermont, New Hampshire with that type of look. And look at this. This is the column max temperature for this time. What is the column max temperature? Well, it's the maximum temperature from about 0 to 500 millibars. So if your maximum temperature is 32 degrees or 0 degrees Celsius, as we're seeing here, well, that means it's going to really all be snow. It's guaranteed to be snow because it's all freezing. Now, if the column max temperature is warmer than 32 degrees, the chances for rain or other types of precipitation are a potential possibility here. And you can see early in the morning during that deformation band developing here, it's kind of in that region. So we'll have to watch that. You can see mixed precipitation south of that. Again, this is going to be most of Maine getting a pretty heavy band of snow. That's looking potentially very likely. This is Saturday morning at 6 a.m. now, that 985 millibar low. And as the storm weakens, that snow's going to spread out. Typically happens as these storms shear out. You'll get some weakening, but the snow will spread out. It'll be lighter snow, but it'll be more widespread. And you can see even all the way through Sunday night, snow for parts of Maine. And again, that usually is longer duration. Snowfall ratios, typically in the band of snow, somewhere between 6 and 12 to 1, which would indicate a sloppy snow. So for every 0.1 inches of liquid, you get like 1 inch of snow. That's kind of regular. It could be less than that, and you could get a sloppy snow. With powdery snow, you want it, with 0.1 inch of liquid, you want more like 2 inches of snow or so. Here's the actual snowfall amounts. Then we'll go over that map that I was talking about. We're going to have a little segment called Model Wars. Which model is going to be doing the best here? This is the NAM computer model. Very, very narrow band of snow. And the issue potentially with this system is dry air getting worked in under that dry slot. If that cold air is slow, or if it's really sharp, but that dry air is really strong, that's going to make that snow band really, really narrow. And the NAM's actually indicating that. The other models a little bit. You can see the NAM, very narrow snow band of 6 to 12 inches, southern Maine. All right, guys, here's the European computer model. It's a completely different story. It's forecasting a major winter storm from Connecticut, Massachusetts, New York, Vermont, New Hampshire, Maine, even Pennsylvania potentially, with as much as 1 to 2 feet. I think that's a little bit overdone, and I think it's going to be just a little bit farther to the northeast than what this is indicating. As you see the GTPS, this is the model that I believe is going to be the winner here, and you can see that there's a decent band of all of Maine, New Hampshire, Vermont, Massachusetts, maybe even Connecticut, and you're talking 2 to 4 inches. And then the heaviest band, as much as 6 to 12 inches, and even northern Maine, clocking in a little bit over 12 inches or so. I do think it's going to be slightly more narrow than what this model shows, and there's going to be a little bit of a dry air issue. You can see that just south of that warm air mass and also that drier air mass. Look how fast that cuts off in southern Maine. So extreme, I think there's going to be an extreme gradient in the snowfall amounts. It's going to be a forecasting nightmare if you're near the seaboard for that location. Just a few miles will make a big difference. And again, guys, there are still inconsistencies in these models. These will change from here on out, and I'll show you my forecast here in a second. And you can see the GFS is similar to the NAM. So let's look at my forecast. This is the areas we're forecasting snow and rain. The rain is forecasted in the green here, where I think there's going to be a less than 20% chance you're going to at least get an inch of snow. The blue area has the most likely area for mixed mode and sleet and stuff like that. But I'm forecasting at least a 20% chance of an inch or more within that blue area. The magenta area, I'm forecasting a 40% chance of an inch or more. The red area, I'm forecasting a 60% chance of an inch or more, with the least likely being Western New York, where I think it's more of like a 50-50 draw. And then the northern here, the northern branch where we're looking at that tan color, that's a 60% chance of an inch or more. That's what it looks like at the moment. There's still a lot of uncertainty in the models, guys. So stay tuned for more videos. This area is looking promising though. So now remember, it's a 60% chance of 1 inch or more. That doesn't mean the maximum area is going to be 1 inch. I think the maximum area is going to be closer to a foot, maybe a little more than a foot, 15 inches plus. So stay tuned, guys. It's going to be a very, very narrow snow band. Again, cold air issues and also maybe some dry pocket issues that could make or break the system. But there is significant lift with this system. So anywhere that there is snow could be intense. You could have a flash or two of thunder. So stay tuned, guys. Hope you enjoyed this video. Again, comment below. Would you like me to create a channel for the East, Central, and West US? Comment below. Hope you enjoyed this video, and we'll see you soon.